Hey everyone, and welcome to this explainer. Today, we're going to completely demystify Scikit-learn for those of you just starting out in Python and machine learning. We are absolutely skipping the scary math, bypassing all that dense academic jargon, and focusing entirely on how you can practically use this incredibly powerful tool right away. So think about this fundamental problem for a second. You've got data, maybe it's a massive spreadsheet of local real estate records or just a giant folder of customer emails. But how do you actually teach a computer to find the hidden patterns in all that data and make accurate predictions from it? Honestly, it sounds a bit like magic, right? Or at least like a monumental programming task that's going to take months to figure out. Well, that is exactly where Scikit-learn comes into play. The big solution here is actually beautifully simple. Scikit-learn, which developers often just call sklearn, is essentially your ultimate, ready-to-use machine learning toolbox in Python. Instead of forcing you to spend weeks writing out complex matrix calculus from scratch, it gives you pre-built, highly optimized tools. You literally just pick an algorithm out of the box, hand it your data, train it, and let it make predictions. It really is that straightforward. To get you completely comfortable with this toolbox today, here's our quick roadmap. We'll look at the machine learning toolbox, the major tasks it handles, and then we'll build your first model. After that, we'll cover training versus testing data, tour some popular algorithms, and finally wrap up with a summary and your best next steps. Okay, let's dive right into Section 1, the machine learning toolbox. Let's define exactly what this library is. So Scikit-learn is an open-source Python library. That means it's completely free, constantly updated by a massive community around the world, and it's incredibly reliable. But honestly, its greatest strength is its emphasis on being ready to use. It basically hands you the perfectly tested hammers, wrenches, and screwdrivers of the machine learning world, all wrapped up in one remarkably consistent interface. Whether you're just prepping data or evaluating a really complex model, the way you interact with Scikit-learn feels logical and uniform every single time. Moving right along to Section 2, Major Machine Learning Tasks. Let's open up those toolbox drawers and see what it can actually do. Scikit-learn handles a few major jobs. First up is classification. Think of a real estate app categorizing a neighborhood as either urban or suburban. Then we have regression, which is predicting actual continuous numbers, like the dollar value of a house based on its square footage. There's also clustering, which is an unsupervised way to naturally group similar data points together, like automatically identifying distinct types of home buyers. And before you even get to those, it handles preprocessing to clean up your data, plus tools for model selection and evaluation to figure out just how well your models are actually doing in the wild. All right, Section 3, building your first model. Let's move from theory to practice and actually build a simple linear regression model right now. We're going to follow a super intuitive 4-step workflow. This is the exact pattern you'll use over and over again. We'll install and import, create some data, fit or train our model, and then make a prediction. Let's walk through it. Step 1, opening the toolbox. In your terminal, you install the package by typing pip install scikit-learn, but check out the second line. Inside your actual Python script, you don't type scikit-learn, you just import from sklearn. So here, we're pulling out the linear regression tool from the linear model drawer. Step 2 is our data. Let's keep going with that real estate theme. Our inputs, capital X, are the number of bedrooms, 1, 2, 3, 4, and 5. Our outputs, lowercase y, are the house prices in hundreds of thousands, 2, 4, 6, 8, and 10. Now, as a human, you can spot the pattern instantly, right? We're just multiplying the bedrooms by 2. Our goal here is to see if we can teach the computer to learn that exact same relationship from just these examples. And here are steps 3 and 4. Honestly, this code is the true magic of Scikit-learn. First, we create a blank model with model equals linear regression. Next, we train it using model.fit xy. Fit is a simple word, but underneath, it's doing some really heavy mathematical lifting to figure out that relationship between bedrooms and price. Finally, we use model.predict and hand it a brand new input, a 6-bedroom house. Based on what it learned, it confidently outputs 12. The absolute genius of this library is that you'll use those exact same .fit and .predict commands, whether you're doing simple math or building highly advanced AI. It's totally universal. That brings us to Section 4, training versus testing data. This is a massive beginner rule we need to talk about. So the golden rule of machine learning is this. You can never, ever evaluate a model solely on data it has already seen. Think about it like a school exam. Your training data is the study guide the student uses to learn the concepts. Your testing data is the final exam. If you give a student the exact same questions on the final that were on the study guide, well, you aren't testing if they learned the concepts, you're just testing if they memorized the answers. We absolutely need a separate test set to prove the model actually understands the underlying patterns. Thankfully, Scikit-learn handles this exact problem for us automatically with a function called train-test-split. By setting test size equal to 0.2, we're telling it to lock away 20% of our real estate data as that unseen final exam, leaving 80% for the model to train on. It does all the tedious shuffling and slicing for you in one single line of code, so you know your model is being tested fairly. Okay, Section 5, Popular Scikit-learn Algorithms. Let's take a quick look around the rest of the shop. Beyond the linear regression we just used, Scikit-learn has a massive array of tools. You've got logistic regression, which, despite its name, is actually used for classification. You have decision trees that make predictions using flowchart-like rules, and random forests, which basically combine hundreds of those trees together for incredible accuracy. There's k-nearest neighbors, which makes predictions by looking at the most similar nearby examples, and k-means, which is fantastic for clustering data points automatically. And remember the best part. You can swap these algorithms in and out of your code using that exact same .fit and .predict workflow without needing to know all the complex math under the hood. Finally, Section 6, Summary and Next Steps. Let's look at the broader picture. Real-world data is rarely as neat as our 1 to 5 bedrooms example. It's usually super messy and requires preprocessing. Tools like Standard Scalar help normalize your data so massive numbers don't drown out the small ones. And once your model is trained, Scikit-learn gives you standard metrics to evaluate its success. For classification, you look at things like accuracy. For regression, you use metrics like mean squared error to see exactly how far off your house price predictions are on average. These are the vital feedback loops that tell you if your model is ready for the real world. But remember, a toolbox is only as good as the person wielding it, right? Watch out for common beginner pitfalls. We already talked about the danger of training and testing on the same data, but you also need to avoid skipping preprocessing or using a regression algorithm for a classification problem. Also, be super mindful of class imbalance. Like, if your dataset has 99% spam emails and only 1% normal emails, your model might just guess spam every single time. It'll look highly accurate, but it'll actually be totally useless. Always choose the right tool and the right metric for your specific problem. It's also really helpful to know where Scikit-learn fits into the larger Python ecosystem. Scikit-learn is laser-focused on the actual machine learning, the training and predicting. But before you get there, you'll likely use a library like Pandas to load and manipulate your messy spreadsheets. And to visualize your data or your results, you'll turn to tools like Matplotlib or Seaborn. Together, these libraries form a complete, unstoppable data science workflow. So we've seen how Scikit-learn turns complex mathematics into an accessible, universal language. You know how to import it, train it, and test it properly. The barrier to entry for machine learning has literally never been lower. So now that your toolbox is open, what are you going to build? Will you predict your company's next big trend? Or maybe just automate away your most boring Friday tasks? The data is waiting out there. What will you build first?